Have you ever wondered how your favorite app just knows what to do when you tap a button? Or, how a video game character decides to turn left instead of right? Well, that's exactly what we're diving into today, the secret logic that powers all software. We call them control structures.
So, let's start with the big question. How does a program actually think? See, when you run a piece of software, it's not just chaos. It's not just randomly firing off commands. It's actually following a path, a kind of journey that's been carefully laid out from start to finish. But what's guiding it? What's telling it which way to go?
And the answer? It's something called control structures. The best way to think about them is like a traffic system for your code. Seriously. They're the road signs, the traffic lights, the forks in the road, all the things that tell your program exactly where to go and what it needs to do next. They literally control the flow.
Okay, so before we get into all the fancy intersections and roundabouts, we have to talk about the default path, the straight road that pretty much every program starts on. This is what we call sequential control.
This is the most basic flow you can imagine. Your code runs exactly the way you wrote it, one line, then the next, then the one after that, right from top to bottom. It's just like following a recipe. You mix the flour, then you add the sugar, then you put it in the oven. No jumping around, no surprises.
But let's be real. Life, and especially software, is almost never that simple. What if your recipe says to add eggs, but you're all out? Well, real programs have to be able to make choices. And this is where things get really interesting. This is where we get to the forks in the road.
To make these kinds of decisions, we have a whole toolkit of what are called selection statements. The most basic one is the if statement. It's super simple. It runs a piece of code only if some condition is true. Then you've got if-else, which gives you a plan B, an alternative path for when that condition is false. And when you have lots of different possibilities, you can chain them together with an else-if ladder or use a switch statement to handle all that complexity.
Now, this slide gets at a really key choice for programmers, if-else versus switch. Let's say you're coding for a coffee machine. You could use a long if-else chain. If the user wants espresso, do this. Else, if they want a latte, do this. But it can get messy and fast. A switch statement cleans this up beautifully. You just look at one variable, the drink order, and then you have a specific case for espresso, a case for latte, and so on. It's way more organized and a heck of a lot easier to read. It's all about picking the right tool for the job.
All right, so we've covered making choices. But what about doing things over and over and over again? I mean, who wants to write the same line of code 100 times? Nobody. And that's where we get the incredible power of loops, or what's called iteration.
We have two main workhorses here. The for loop is your go-to when you know exactly how many times you need to do something, like count from 1 to 10. Easy. The while loop, on the other hand, is for when you don't know. It just keeps on running while a certain condition stays true, like waiting for a user to finally press the quit button. The one thing you have to be careful about with while loops is making sure that condition can eventually become false. If not, you get an infinite loop, and that's a classic bug that'll freeze your program solid.
And then there's the quirky cousin of the loop family, the do-while loop. So what's its special power? It always, and I mean always, runs at least one time. That's because it does the work first and only checks the condition at the very end. This is actually perfect for things like showing a user a menu of options at least once and then asking if they want to see it again.
Right, so we have loops that are designed to go around in circles. But what if you need to get out early, or maybe just skip one of the laps? For that, we have special commands called jump statements.
This slide shows the difference perfectly. Think of the break statement as the big red emergency stop button. You hit it, and you are immediately out of the loop, completely done. But continue is different. It's not an emergency exit. It just says, you know what? I'm done with this particular lap, and it skips right ahead to the start of the next one.
Okay, let's walk through this to see it in action. Let's say we're in a loop that's printing numbers from 1 to 5, but for some reason we want to skip printing the number 3. So the loop starts. It prints 1, it prints 2. Then it gets to 3. Our if condition is now true, which triggers the continue statement. And boom, it immediately skips the print command and jumps right to the start of the next cycle. So what happens next? It prints 4, then it prints 5. The loop finishes, and we've perfectly skipped just that one step.
So we've looked at how programs can follow a straight path, how they make decisions at forks in the road, and how they repeat actions in loops. Now let's just pull back for a second and put all of these powerful ideas together.
When you get right down to it, everything boils down to these three fundamental ideas. You've got sequential flow, that's your default, straight road. You've got selection, those are the forks in the road that let your code make choices. And you've got iteration, those are the loops that let you do things over and over again efficiently. Literally every single program you use is just a clever combination of these three structures.
And honestly, this is the most amazing part. From the simplest calculator app on your phone to the most mind-blowingly complex video game or even a computer's entire operating system, every single piece of software is built from these exact same, relatively simple building blocks. They're like the atoms of digital logic.
So yeah, sequence, selection, and iteration. With just these few simple rules, you can literally build entire digital worlds. It kind of makes you wonder, doesn't it? What will you build with them?